Hi guys, today we're gonna start our Unit 3 linear equations, and our first lesson is on solutions of linear equations. First, let's talk about what linear equations are. Linear equations looks like any other equations. It is made up of two expressions equal to each other. A linear equation is special because it has one or two variables. No variable in the linear equation is raised to a power greater than 1. The solution for the linear equation is a point that makes the equation true, and you can plot this point on the coordinate grid. So the main thing here to know that we have no power greater than 1. That's the main thing. And that the solution is a point that we can graph on the grid. The solutions for any one equation lie on the same line. So all the solutions lie on the same line. And that linear equation's graph is a straight line. All linear equations can be graphed as straight lines. So how do we evaluate linear equations? Let's take a look at this example where we have y equals negative 2x plus 6. So I'm trying to evaluate this linear equation when x equals negative 2. That means that instead of x in the linear equation, now I'm going to have to substitute the x with negative 2 and evaluate for y. So when I switch x with negative 2 in this equation, I end up with a value for y, and this value is 10. Negative 2 times negative 2 is 4 plus 6, and the solution is 10. Now the solution for the linear equation is a point, as we said before. And this point is going to have an x-coordinate and a y-coordinate, which is in this case negative 2 and 10. Now let's evaluate the same equation when we have x equals 1. So again, I'm going to take out the x, and instead of x, I'm going to switch the x with 1. And now the final answer for this problem is going to be y equals 4. Now that doesn't mean that the solution is 4. That means that the solution is the x-coordinate, which is 1, and the y-coordinate, which is 4. So the solution for this linear equation is 1, 4. Now let's talk about the intercepts. And the first intercept is the x-intercept, where the line of the linear equation intercepts or intersects the x-axis. The y value for the x-intercept is 0 because the intercept is going to cross the x-axis at a point, and this point has a y-coordinate of 0. And the only value that we have for this point is the x value. The second intercept is the y-intercept, and the y-intercept is a point where the line of the linear equation intersects the y-axis. At that point, the x value for that point is going to be 0. And the only value that we have for this point is the y-coordinate. So again, the x-intercept intersects the x-axis, the y-intercept intersects the y-axis. The y value for the x-intercept is 0. The x value for the y-intercept is 0. Now let's take a look at this example to find out what the x-intercept and the y-intercepts for this equation are. So let's start with the x-intercept. We know that the x-intercept is a point that has a y value of 0. So to find the x-intercept, I'm going to have to substitute y with 0, and then evaluate the linear equation. So in this case, I'm going to have to take away 2x to the other side, positive 2x. I'm trying to make my linear equation positive. And then I'm going to end up with 2x equals 6 divided by 2 divided by 2. I'm going to end up with x equals 3. So now the x-intercept for this linear equation is 3, 0. And if we graph this linear function, which we're going to learn in a few minutes, we will see that the line of this linear equation intersect the x-intercept at 3, 0. Now to find the y-intercept, I know that the x-coordinate of the y-intercept, or the point of the y-intercept, is equal to 0. That means I'm going to substitute x in the linear equation with 0. So I'm going to go back to my function, or to my equation. I have y equals -2, and I'm going to substitute x with 0 plus 6. Now the y value, when we evaluate this linear function, is y equals 6, which means that the y-coordinate of the y-intercept is 6. This means that this linear equation has a y-intercept that intersect the y-axis at point 0, 6. We talked about what linear equations are. We talked about the intercepts. Now we're going to talk about the forms of linear equations. The first form is the slope y-intercept form, which is we're going to use a lot, and this form is equal to, or has the y equals mx plus b form, where m is the slope of the line, which we'll talk about next class, and b is the y-intercept value. And in this form, a y is isolated. Y is by itself at one side of the equation. The second form is the standard form, and the standard form is ax plus by equals c, where a, b, c are real numbers. They are numbers. And if you look at this form, you'll find out that x and y are together at the same side. X and y are together on the same side. Now let's take a look at this example where we have to write the equation in the slope by intercept form and then change it into the standard form. So I'm going to start with the slope by intercept form, where I'm going to have to isolate the y. So I'm going to start by using the distributive property. 3 times x is 3x. 3 times -3 is -9 equals y minus 6. Now I know that I need to isolate the y. That's why I'm going to take away 6 from both sides. And when I do that, I end up with 3x minus 3 equals y. And this is the slope by intercept form for this linear equation. Now I'm going to do that, or change the equation again, but this time to the standard form. So I'm going to have to distribute again. So I have 3 times x is 3x. 3 times -3 is -9 equals y minus 6. Now this time my goal is to have x and y on the same side. So that means I need to get rid of 9 first. So I'm adding 9 to both sides. I'm going to end up with 3x equals 9 plus 3. X and y are on opposite sides. I need to bring them together on one side. So I'm going to take away y from both sides. I'm going to end up with 3x minus minus y equals 3. And that's the standard form for the linear equation.